Alright, video number 2. Let's go. More pure algebra. Bite sizes. I would recommend your good friend PEMDAS when you get cranked on this. So look, P, focus on clean stuff up inside parentheses if possible, and it is possible. So I notice there's a 2 here, there's an invisible one there, so I'm just going to kind of make a big line. I know there's a 1/2 floating around. M squared over M, I can take an M out, and I can take an M out, so I'm left with 1M. The end of the fourth is just stuck. This drops underneath, joins its pal down there, so we got P squared and another P gives us P cubed. Times. Now I'm going to go ahead and go power to a power here. So there's an invisible one there, there's an invisible one there. I'm going to take my time and go 5 to the -1, M to the 1, because -1 times -1 is +1, N as in Nancy to the -1, and then P to the -3. Anything, and this is to be thought of as all over 1. So this has to go to the denominator, this has to go to the denominator, so here we go. Everything else, M, stays up top. So that's a 5 down there, N as in Nancy, P cubed. So now we have fractions, so we should try to look to reduce diagonally. I can take an N out of N, divide it by N, divide that by N, I'd end up with N cubed. And that's it. So now I multiply straight across. M times M is M squared. And then I get 5 times 2 is 10. P cubed times P cubed is P to the 6th. Did I forget? Yeah, forgot my N cubed. Almost. There it is. So organization. So maybe you want to use colors so you don't do what I almost did and forget something. Just keep track of your progress. Next problem. Square root. Well, we're going to break that 150 into a couple parts. 25 times 6. Now there's an invisible 2 there. What's the first number less than 9? That 2 goes into evenly. 8. And then I'm left with 1. And this just happens to be perfect. 12 divided by 2 is y to the 6th. So there's a 5. There's an x to the 4th, because 8 divided by the invisible 2 is even. So I'm done with that, done with that. I got that y to the 6th. And now these things just reunite like good old friends. Alright, there we go. Let's go on to the next one. Again, bite-sized pieces. 4 squared, nothing to simplify inside here. So 16 x squared y squared z squared, because there's a 1 there, a 1 there, and a 1 there, multiply, times 2 cubed is 8, power to a power, x to the 6th, same thing, 9th, same thing, -15. Now we'll deal with this. So I'm going to just x that out. I'm going to put it all over z to the 15th, and that's gone. So now, here we go. 16 times 8 is 144. Is that right? No. 80 and 48, 128. X squared times x to the 6th, x to the 8th, y squared times y to the 9th. We're adding exponents right now. And I can see I got 2 z's here, 15 there. Take 2 out here, take 2 out there. I'm left with 13s. So that would be all over z to the 13th power. Shazam. Alright, good old classic math problem. Here comes a big guilt trip. You've been doing these since probably 5th grade. Write an equation of a line. That means you're not done until you find the slope and the y-intercept. Well, notice they gave you the slope, so put it right there. So y equals -2x plus b. So what am I trying to find? My y-intercept. Drawing a picture won't be great because your picture's not perfect. So algebra is perfect. And so we're going to take this little extra clue they gave us. Now, if they did give us a clue that the point that it went through was 0, 8, that's just a different way of just saying let b equal 8. That's our y-intercept. But they didn't do that. This is not your y-intercept. So you got to go y equals m x plus b. That's negative 8, so I'm going to add 8. So 8 minus 3 is 5. So my answer would be y equals negative 2x plus 5. It wouldn't be a terrible idea to plot this point. 1, 2, 3, 4, negative 3. And then if my slope is negative 2, my y-intercept is supposed to be 5. So I'd be down 2, right 1. And it looks like it might just get up to 5. So it kind of verifies our thoughts there. Okay, Unit 2. For each of the following angles, give both a positive and negative coterminal. Coterminal means they land right on top of each other. So the first thing we have to do is figure out what this is. Pi over 3 is 60, and 2 times that is 120, so negative 120. So that means we spin our spinner down 90 degrees. Keeping track of this is somewhat beneficial. 30. And that's where our original spin stops. So, what would a positive one look like? Well, it starts here and it goes there. So, very simply, you could find it by just saying 360 minus 120, which is 240. Convert the original angle to degrees. So, I guess they're, all right, we already did that. They're not saying convert your answer to radians, so I'll leave it there. But if they ask you to convert it to radians, you ought to be prepared. So that's the positive one. What's a negative one in this case? The negative one means start here, go there. So that's negative 120, and then continue for another full revolution, which means just add another negative 360. So that would be negative 480. Those are my 2 coterminal spins or angles. This one, what's pi over 6? Well, that's 30. So 13 times 30 be 390. So we get our original spin spun. So 390 just means go 360 plus a little 30 action there. And there we go. So the positive one is the easiest one. Just spin it 30. So another way of getting there is 30. And the negative one would be just to go this way. So that'd be 360 minus 30, which is negative 330. So there's my negative one, there's my positive one. They both land right here, just like this one did. So there's your little lesson on coterminals. Now for the graphing of sinusoids. All right, well, first of all, cosine. It doesn't say graph 1 period or 2 periods, so we'll just go with 1. I personally like a little bit that way and a little bit this way. So I'm going to stick with that. So what's my parent function of cosine? Remember, it goes over the origin. So it looks like this, with a little ish. So there's 1 period, which is 2 pi. Don't forget that. Your formulas hopefully are given to you. There's the amplitude formula, and then the period formula is 2 pi. Don't forget, that's a hint. That's your normal period over b. Technically, it's the absolute value of b, but very rarely in this class has b been negative. So now we got to do some work. 3. Well, that's my a. So where do I put that? Right here. What does that do? Well, a lot of students add 3, and I get it, but it doesn't make sense because it's 3 times the original amplitude, so it's going to go 3 times 1, which is up to 3. 3 times negative 1, which is down to negative 3. So my peak goes up to 3. 3 times 0 is just 0, 3 times 0 is 0, 3 times negative 1 is negative 3, and so on. And there it is. Problem is, we're not done. So my b is 1, which means my period's not going to change. It's still 2 pi. But we need to bump this thing to the right pi, which in my drawing is 2 chunks. So, the grand finale. This needs to move 2 chunks to here. This needs to move 2 chunks to here. This needs to move 2 chunks to there. And that would actually move, hold it, this would actually move to there as well, just to give me a little target. And then that would move to here. And I can really see what it looks like. So there you go. And if they wanted another one, you could just add another one. All right. Let's go on to sine. Sine, remember, I like a little on this side, negative. I forgot the negative over here, my bad. And then pi over 2, pi, 1, negative 1. So what does our parent function of this look like? I'm going to make it dotted. It goes through, goes up to 1, because we know sine of 90 is 1. We better know that. And there it is. Now, why did I make it dotted? Because of that. What does that do? It's going to be over the x-axis. So that means I just flip it, like so-ish. There. But we're not done. We got some work to do. I'm going to attack the period first. There's an invisible 1 there, which tells me my b is 1/4. Some of you haven't gotten comfortable throwing fractions in the denominator yet. You just need to get comfortable, because that's just the same thing as multiplying by 4. You multiply by the reciprocal. So this turns into 8 pi, which, don't forget, our original period is 2 pi, which means we've got pi on this side, pi on that side. That's why I like a little bit on the left, a little bit on the right, and now I'm just going to stretch it. 4 pi, which means 4 pi on this side, 4 pi on that side. And so I should have made my units a lot smaller. Oh well. So there's pi. And so from here to here is pi. So here's 2 pi. Here's 3 pi. I'm going to squeeze this in. And here's 4 pi. So you see this chunk right here? It needs to, the halfway point for this is pi over 2. The halfway point of this is going to be here. So I'm going to get out a yellow marker and make my goal to go like this. And just get stretched like that. Now you need to do the same thing over here. It's going to get a little crazy, but pi, 2 pi, 3 pi, 4 pi, and that needs to go up, I'm guessing at the halfway point, and then down. Perfect? No. It's going to get the job done? Sure. And now I need to bump everything up too. And we'll make the grand finale green. So here comes the grand finale. Everything's got to go up 2. So this is going to go up to, there's 2, 3. So that goes up to here. This goes up to here, to 2. Hopefully I got up there. And then this goes up to 2. So it's just the same. It's almost parallel, like this. And then this goes up 2, which is right there. This goes up 2, which is there. This goes up 2, which is here. So that's the down and up portion. There she is. It's a lot of work. All right. Let me pause this just a second. Okay, last problem, I think, for this part 2 video. And I added something here. It says write a possible equation. So what they're saying is you could use sine or you could use cosine. I'm going to go with what I think the easiest choice is for this one, and it's cosine. Because if we look at our cosine parent function, it just goes over the origin, and that's what I'm seeing right here. Yeah, you could talk about sine, but then you'd have to bump it right or left, depending on if you started here or started here. It just, introducing sine, I think, just makes it a lot more difficult. So we're going to stick with cosine. So we're going to stick with the basic, and we're going to build. First thing that jumps out at me is the amplitude right here. It goes 2, 4, then 5, and it stays consistent below. So I'm going to add the 5. There's my amplitude. There's no negative because it hasn't been flipped. The next thing that jumps out at me, and I can tell there's not going to be a shift right or left because that thing just kind of mirrors that thing. So it hasn't been moved at all, right or left. But here's what's jumping out at me. I got the period 8 pi from here to here, another 8 pi, so the total period is 16 pi. So I got to kind of think backwards using this formula. So the period is 16 pi, and that's going to equal my formula 2 pi all over b. And you got to do a little math here, multiply by b, because we're trying to solve for b. So I'm going to clean this up. So 16 pi b, awfully weird looking, equals 2 pi. Divide by 16 pi, divide by 16 pi, the pi's cancel. I reduce that and I get 1/8. So I take this and I say that can't be my final answer. 5 times cosine of 1/8 x. Yes, you could use sine. See me if you're curious about what those answers are. We'll play around with it, but I'm not going to burn up video time. So that's it for part 2.